Hello, welcome back from your break. Today we're starting on interfaces. Good times. Our next unit, and pretty much our final big piece of inheritance kind of knowledge that we're going to learn this semester. So there'll be a few more things we learn this semester beyond interfaces here, but this is probably going to be the biggest, major topic that we're going to look at for the rest of our time here. Let me bring the bars back. Just love those bars. Okay, let me do a poll, I guess, just to see if everybody's alive and paying attention. We'll see how many people have GitHub set up yet. Git integration set up yet. I know I've been asking this pretty much every day, but it is very, very useful if you get it working, because then you can synchronize with what I'm doing as I'm doing it live or after class, and helps make it available for you on the exam. So a lot of people, it looked like they didn't have all the examples pulled up on the exam. If you had your Git integration going, you would have been able to get those pulled up very quickly. So once again, just see that you have it installed, because if you do, then the steps you have to take are really minimal here. You just have to go to Show View, Window, Show View, Other. And if you've got this Git folder here along with your Git repository as an option, then you must already have the Git integration with Eclipse installed. You can show that Git repository's view, and it'll come up wherever it is you put it, this little guy here. And from there, honestly, it's pretty self-explanatory. You could probably do it without even following along with the tutorial. Just hit that little clone button there with the green arrows and pick a project to stick it in, and put that link that I gave you to the repository. I think that should be pinned in Discord. It is, so it's pinned in the general chat. And that pretty much gets you rolling. So give it a shot if you haven't already. There's not much more I can say beyond that. Alright, today we're going to be looking at interfaces. Again, interfaces are our new thing today. And to start, I'm going to ask you a couple of little real-world questions. So we kind of represent nouns as objects already, and we kind of represent verbs as functions already. But what's missing in object-oriented land? What do we never really have the opportunity to express very well? If we got our nouns are our functions, and our verbs are our verbs are our functions and our nouns are our objects, what do we not get the opportunity to express when we do object-oriented programming? And this is one of the larger criticisms of object-oriented programming, by the way, and object-oriented languages, is that adjectives. They kind of fail to represent adjectives very well. There also is this sort of problem with the way that we have to represent functions as verbs and objects as nouns, generally speaking. How come every verb, so every function, has to be tied to a noun? Hold on a second. A little more light there. How come every verb has to be tied to a noun? Aren't there some verbs, some actions out there we could take that shouldn't belong to any object, that should just be on their own? That's the other major criticism of object-oriented programming that comes from kind of the words domain. So we can't represent adjectives, and every verb has to be bound to a noun, even when possibly either that action isn't actually bound to any object, it's something that the program does maybe in general, or it's an action that's bound to a lot of objects. And that latter case, the action being bound to a lot of objects, is what we're solving with interfaces to an extent. And the lack of adjectives is also something that programmers will often solve using interfaces instead. So let's look at a couple of the interfaces that we've seen already, so that I can talk a little bit about what I mean by that. So before we even look at what they are, we have these two interfaces that we've been using without really explaining them. So interfaces use that keyword implements, which we'll look at more, but we've got these two, mouse input listener and key listener, that we've been using this whole time. And we know that after we invoke those, they generate all these different methods for us there. And let me make my text a little larger. Should be good. What kind of words are those? Are those nouns, verbs, adjectives? What is mouse input listener? What is key listener? Those are nouns, right? So what do I mean by that we can represent our adjectives here? Well, we've got a bunch of different functions, the clicked, entered, pressed, released, dragged, etc., for each of those different things. And this allows us to take these verbs, the clicked, the entered, the exited, the pressed, and apply those to a lot of different, maybe components, different kinds of objects. So we have our two interfaces attached to a panel here, but we could actually attach these to other things too. You can attach listeners to squares, you can attach listeners to buttons, you can attach listeners to all kinds of things. So it allows us to take this set of verbs, clicked, entered, exited, pressed, and apply those to different objects by implementing this interface. So that's the first power that we have available there. Okay, so without getting more into complicated language junk, let's get right into the interface intro. So I'm going to make a new package called interface intro. Close out of this guy. And there is a simple way to make interfaces in Eclipse that you can use, or you can simply create regular classes. You'll probably notice when you go to create a new class here, what's right under it? Well, interface, actually. And there's also enum, which we learned about earlier, too. So this is actually a shorthand for making an enum. I told you a lot of the times people will make enums in their own class, so that's what you have here, the ability to make an enum as a class, instead of having to include it in your class. Again, that avoids having to use that annoying class keyword every time you want to invoke the enum. This class dot the enum name dot whatever. If it's just its own class, then you can skip the this class dot part. So you can make interfaces like this here. You'll notice that if you choose that option, the dialog is a little different. So that's the interface dialog, and then compared to the class dialog where you have some more options. That's because interfaces actually have fewer options available to you than do full-fledged classes. And how do you make an abstract class? Well, remember that was just a checkbox here, and so is the main method and all this different stuff. So, all right. Let's go to the interface creator there, since we haven't used that yet. And actually, first let's create an object, and then we'll go through with the interfaces that it might have. So I'm going to use a classic example. I'm going to make a class called car. And there's my car. That's a regular class, not an interface. And then I'm going to go and make a new interface, and then we'll think about this for a second. So an interface allows multiple classes to share kind of behaviors, but at its core, what an interface is, and this is what I really want you to remember about interfaces, is that they come from a system of basically contracts or promises. So at their core, a interface is a list of promises that the class that implements it will have. So an interface just specifies a list of things that anything that implements it must implement, must do, must have. And let's check out how that might work in principle and why that's so useful here. So I'm going to make one called, let's call this ignition. Okay, call it ignition. Here's my interface ignition. And I'm going to have car. Remember that keyword is implements. It's going to implement ignition. So car implements ignition. We haven't done anything with ignition yet, so it's still going to be blank. All right, so list of promises. The list is formatted in the same way that we saw with abstract classes when you want to make an abstract method. So when you wanted to make an abstract method, you use this syntax. You set public abstract void, some method, and then you maybe took some args, arg1, 2, whatever, and then you just terminated it, right? You don't need the abstract keyword here in the interface, so it's just this. The abstract is implied because interfaces cannot have code in them. It's actually not entirely true, and we might look at that later, but for now you should just consider that to be true because that is the standard practice. Interfaces don't have any code. Instead, interfaces just have a list of the methods that you promise to have. So if you have a car and your car has an ignition, and this is kind of the terminology that we use when we think about interfaces. We think that the car has a, and then whatever its interface list is. So if we went back to our swing intro or our swing starter here, and we looked at the display, we would say that our display is a JPanel because it completely extends JPanel. It inherits all of its methods and properties, and it can use the methods and properties from the superclass, any of the ones that aren't private. So it is a JPanel completely in terms of functionality, but it has a mouse input listener and a key listener. So is a JPanel, has a mouse input listener, key listener. Sometimes this can get a little bit fuzzy when we end up naming our interfaces adjectives, which is why a lot of programmers will follow the preference of basically nominalizing their adjectives. So if you think about it, the mouse input listener and key listener could have been expressed in their adjective form, which is something like, I don't know, listenable or mouse listenable or key listenable, but that would have been kind of awkward for naming, and then it also doesn't really make sense with the has terminology. So most programmers that use interfaces will tend to nominalize them, so they'll take whatever adjective they meant to use and they'll just turn that into a noun. End up calling it key listener or something. And that makes you unfortunately end up with a lot of interfaces that have awkward names like something manager, something communicator, something controller, and that's kind of just the way it is when you nominalize adjectives. All right, anyway, back to ignition. So if a car has an ignition, what are a couple promises that an ignition should guarantee? What are a couple of the things that an ignition would guarantee to a car? In either chat, what are a couple of the promises that an ignition might guarantee to a vehicle? What should anything that has an ignition be able to do? And this is a good way of thinking about your interface design. What should anything that has this interface be able to do? Yeah, we got like from YouTube chat crank, so let's go with crank and then start. Those are probably two of the things you should be able to do. And if you can start, it also follows that you can probably stop. Okay, I'm going to get rid of some method because we don't need it. None of those really have arguments, but I'm going to go with, let's call it power for crank. So it's how hard you cranked it. And I'll even write a comment there. So attempts to crank the engine by turning the key this hard. Okay, those are reasonable promises that an ignition might offer to a car. But let's make another interface. Let's say that this car also has an engine. Engines can start too, right? Engines can also start. So that puts us in a little bit of an awkward position because, well, we already have a start in ignition. Let's see how we might deal with that later. So first, you'll see that an error came up as soon as I saved my ignition method, because again, an interface is a promise to implement all of those methods, and as long as you haven't, you're not compliant with that interface. So I'm going to add the unimplemented methods there automatically. It'll generate stubs for them, and you notice this is exactly what happens when you deal with those mouse and keyboard listeners in your display examples and your panel examples. So let's say that if crank is greater than 5, then we're going to call start. And you notice that we are, power, call that if power is greater than 5, we're going to call start. You'll notice that I have the start and stop method already, so that works just fine. And you also notice if I hover over crank, I can see the documentation from the interface. So one of the big advantages of interfaces is actually the shared documentation. So even if you have a lot of different functions, a lot of different objects that do a similar thing in a slightly different way, a lot of the time you will want to make an interface for that slightly similar thing just so you can write a single comment, a single piece of documentation that covers the way that those things are similar, and then you might add additional documentation to each of them to describe maybe some of those differences if those are important. But the interface allows you to write a single comment for all of your different similar things here. Alright, so we've got our crank start is just going to say, let's go vroom. We'll do some more with that later. And stop does the opposite. We'll call it not vroom. Okay, let's go ahead and create a driver class. So with the main method, I'm going to check that box here. And by the way, the terminology driver, I probably mentioned this before, kind of comes from this idea of the car example. It's the thing that drives the code. So anyway, let's go and make a car, new car. And of course, I can use all those methods that the interface guarantees to me. So I can try to crank with, let's say, 10 power. And if I run this, that's going to print vroom for me. Lovely. Okay, so I want to add some additional functionality here. I want to crank the car. If I successfully start it, I want to turn the engine on. And then when the engine is cranked and on, it's running or whatever, there's some variable that lets me know if the engine is on. And then when you turn the ignition to stop, I want to turn the engine off. Right? So what do I need in engine in order to accomplish that functionality? So when you turn the ignition, when you crank it, it starts the car. We've already got that going. So I want to turn the engine on. I want to have some variable that tracks whether the engine's on or off. And then when you turn the key to stop, I want to turn the engine off. What kind of stuff would we need to add to engine in order to accomplish that? A lot of these early examples we're going to go through, while you're thinking about that, they're a little contrived in the sense that maybe they're not best done with interfaces. And there's going to be a pretty good reason for that, and that's because you really don't need interfaces that much until you've got a lot going on. If you lead with interfaces, you're going to violate one of the most important principles of software development, and that's Yagni. You ain't going to need it. So unfortunately, oftentimes it's not explicitly clear. So alright, we want some kind of, like a Boolean is running or something, right? A Boolean is running. But here we run into a problem with interfaces. So all objects share this interface. Everybody that implements it shares it. And because of that, any variables that an interface has are automatically shared. That means they're all static automatically. So we even see that it's highlighting it in italics, as it does for statics. This is a little bit of an annoying feature in Eclipse. 5. This is a little bit of an annoying feature in Eclipse, and I guess in Java in general, that it allows the syntax. What it's actually doing for me here is public static final. That's actually what it's doing for me. It's just allowing me to skip those first few keywords because for an interface, everything is automatically public static and final by default because everything that implements this interface will share that is running variable. Okay, so anything that implements engine will share the same variables. That means that we can't have variables really on an interface. We can't have fields. So we can have static final fields that are shared across all of the different things that implement them, but we can't have fields that are different for each object, which is usually what we're going to want to have. Especially for this engine, we want to see if each individual engine is running. So let's say, for example, we have Going back to the driver, we have two cars. So I have my other car here. We certainly wouldn't want them both to share an engine. When you crank car 1, it shouldn't turn on the engine for car 2. So we definitely don't want our is running to be static. So given what you know so far, how can you guarantee that anything that implements an engine is going to be able to check if it's running or not without having a variable that tracks that on the interface? So how can the interface promise that anything that has an engine can verify if it's running or not without giving you a variable that you can check there? And then somebody indicated that we want a stop method. So we'll give that a shot too. We got a stop method. How can our interface promise that there's going to be a way to check if the engine is running without offering you an is running variable? So I'll leave a little comment here. We can't do this because all variables on an interface are automatically static. More specific, let's say fields. Yeah, so we can make that guarantee from the YouTube chat by offering a check running method, right? So if we have a check running method, which is going to return Boolean, then we make a guarantee that any object that implements an engine should have some kind of functionality to see if it's running or not. So I'm going to comment this out. Let's write our documentation for checks running returns true if the car has been started. Okay. So a check running method, and then we have a stop. Let's see how that looks like when we go back to our car. So I've saved engine. I haven't implemented here yet. Now remember, we can only extend one thing. There is no such limit for interfaces, which is how we get into multiple inheritance in Java. So the other use for interfaces is to be able to build those multiple inheritance hierarchies. Although those are dangerous and quickly become very confusing, this is still one of the ways to do it. Now, rather than thinking about it as a multiple inheritance hierarchy, I prefer to think of it in terms of components. So I prefer to think of it not that a car, again, it's not is-a like extends, it's has-a. So you can think of any interface that an object has as an aspect of it, a component of it, an element of it, a property of it. That's why I kind of go back to the adjective instead of the noun version of interface, because these are things that the object has. They're like properties, but they could also be things like an engine. You have an engine. That's not an adjective. It's actually an object. That's a part of cars. All right, so if I add the unimplemented methods here, okay, I've got a little bit of a problem, don't I? I've got a stop method here, okay, and then I've got a stop method on ignition, and then I've also got a stop method on engine. So which one is it using? Which one is it actually going to use? If I hover over it, I actually don't get any hints here. It tells me it's interface intro dot stop. Let me write a comment for both of them and see which one pops up. So let's say turns the key to stop on this one here. On the engine, I'll say stops the engine. Okay, which one is going to pop up there? Let's see. Both is the answer, both. And I believe in previous versions of Java, this would actually just be an error because it would see that it was ambiguous. I think this is something that they added in like 11 or 13, somewhere around there, the ability to specify the same method in an interface. It's still something in two different interfaces. It's still something that you probably want to avoid, because this kind of ambiguity is really dangerous, because you don't know which one is going to be called. Let's see if I can get it to error out due to ambiguity a little bit later too. Let's see if I can do that. All right, so check running. How do we complete this? How can we return true if the car is running? How can we return false if it's not? How do we fulfill this promise and implement the functionality the way that it's supposed to be done? So the interface made a promise, and we actually documented that promise in a comment. We said that this has to return true if the car has been started. I actually shouldn't have said car there, because it might not necessarily be a car. So let's go back and say returns true if the engine has been started. It could be any engine-bearing vehicle. So how do I fulfill this promise? How do I implement this function? Yeah, we need to check whether the start method has run, and more specifically, if start's run and then stop hasn't yet, because you can also stop the car after you start it. So we need a field. And this is the common pattern that you're going to see. You're going to see an interface make a promise. So the engine guarantees that you'll be able to check if it's running or not. And then in your implementation, so we refer to the class actually implementing the interface as the implementation sometimes. Makes sense, right? It implements an engine, so it's the implementation of an engine. Here is where we would actually have that field. So let's call it private boolean is running. We're going to start it off at false. And here we're actually going to return whether the car is running or not. And we're going to obviously set that to true when you hit start there. You're going to set it to false when you hit stop there. Okay, so let's go back to the driver and try this out. So I got my two cars there. If you crank it hard enough, remember that if you crank it with more than 5, it's going to start and then it goes vroom. Okay, so let's go with we cranked it, and then we're going to check if it's running, and then we're going to try to stop it. And then we're going to check if it's running again, and I'm going to need to print out check running, so I'll use my fancy trick to get those printed quickly. And if you've forgotten the trick over the break, remember you can highlight anything you want to print, hit Control Space, start typing sys out, or use the arrow keys to get to it, and then hit Enter, and you get the whole thing inside system.out.println. If you've made a mistake at any point during that process, you have to undo and start over. So good careful typing. If you have a keyboard with macros, I suggest this be one of the ones you use. So one more time, it's Control Space with whatever you want to print out highlighted, start typing sys out, or use the arrow keys to get to it, and then hit Enter. Alright, so what should this print do? Well, we should have We should have a true, and then a stop, and then a false. So let's see. True, false. Right, true, false. Okay, which stop got called here? Which stop ended up getting called? Was it the stop in ignition or the stop in engine again? The ambiguity here. Which one got called? Was it both? How can we tell? complicated. So avoid that kind of ambiguity if possible. Try not to name your methods the same thing in the interface. So what could I name stop instead that's maybe less confusing or doesn't have intersection with engine? What might I name it so that it doesn't intersect, so engine and ignition don't step on each other's toes? Sure, we can have a stop engine. I don't want to get too specific, but sure. And of course, as soon as we change it to that, we're now no longer in compliance. So we go in with cease. If you start playing the synonym game, you can, but you'll never escape it. You'll end up with stop, cease, desist, halt. All right. Do we want to do anything different when stop engine is called? How do we want to... Do we want to refactor this at all? Is there something to terminate, etc.? Do we want to refactor this at all? Do we want to change it to be more representative of the way we expect those interfaces to work? What change should I make here? As a hint, remember, stop is when you turn the key to stop. What happens when you turn the key to stop? Or what should happen when you turn the key to stop, besides the fact that it says not room? Yeah, the engine stops. So realistically, when you turn the key to stop, we shouldn't be setting is running to false. That should be the responsibility of stop engine. When you turn the key to stop, we should call stop engine. That would be a more probably appropriate way to hand those behaviors out. So an ignition could actually do a lot of other things too, right? It could validate that you have the right key. So ignition could be a pretty big high responsibility interface. We did some pretty simple examples here, but it could be responsible for a lot more. So let's do a more adjective-ish or adverb-ish oriented kind of interface. So let's say that you have a car, it has an ignition, it has an engine, it probably has a bunch of other parts. Let's describe another aspect of it, that the car is, let's say, able to move in our scene. So let's call it another interface. I'm going to call this movable. And so I mentioned that a lot of programmers will take their adjectives or whatever and they will nominalize them. So if you're in that camp, perfectly fine. A lot of people say never use adjectives, which means that there are no adjectives at all in object-oriented programming, since we've already got our class names as nouns and our functions as verbs. That leaves us no place to actually put adjectives except possibly in fields occasionally. But what would you call movable if you didn't want to use an adjective? So let's say that I want this to be the car's ability to move. The car has an ability to move. I called it movable. Can anybody offer a good noun version of movable? Car has the ability to move. I'll let you know what the the common ones that people use are after you give me some guesses. I got mover is a good guess. Mobilize, that's not a noun, I don't think. That's a verb. You would name your interface a verb. Mobilizer, maybe? So vehicle would describe a car in general, but not anything that's movable. This doesn't describe just a vehicle, it's just the ability to move. A noun that describes the ability to move. mover, mobilizer, both kind of complicated, but I guess good ones. So the common ones you'll see will be something like transform, or you could even use the more primitive like position, because if something is movable, then it has a position. Does that make sense? So if something is movable, then it has a position. The problem with position is that it doesn't imply some of the other stuff that being movable implies, like that you can actually change position. So a lot of time you'll see transform instead. If something is movable, it has a transform, which is a position and the ability to change that position. I'm going to go with movable though, because I find I guess the adjective version to be less confusing. So here we have an interface that's named with an adjective. So what guarantees do you have to make in order to be an object that can have a position somewhere on the screen, let's say, because I'm going to draw these to the screen soon. So something that has a position and can move. What guarantees do you have to make? And we'll say 2D to keep it simple, so 2 dimensions only. It needs an X and a Y, right, from the Discord chat. We can't put it in the interface because our interface only lets us have public statics and finals. If we wanted to do physics, which is not necessarily a guarantee of being movable, someone recommended in YouTube chat we do a certain speed and acceleration, that would be good too. If our implementation of movable was physics-based. I'm going to keep it a little simpler than that now, though, because we don't really know how to animate very well, so that stuff wouldn't really help us too much here. We only move things with the arrow keys for now. We might do a little animation in the next few weeks, though. So you can come back to speed and acceleration soon. Put a pin in that. But we do need an X and a Y, so how can we guarantee that anything that's movable will have an X and a Y? And again, we can't put those in our interface fields because they're shared by all who implement them, and they'd be static and final, and then everything would have the same position. That would be bad. So we're going to have a place method. What does the place method do? Take any arguments or do anything? What's the guarantee that we're making with the place method? Alright, we'll take an X and a Y, and it sounds like, I'm going to make an assumption here, we want to place this movable object at the given position. So we want the ability to put this object somewhere. That might be important. Yeah, that might be useful. Okay. We still haven't guaranteed that it has an X and a Y for us to place. Not really, or at least you would need to know that you need to have that. So let's say you're implementing this interface and you don't know any of you didn't look into its source, you just have the comments, you just have this place method. You don't really know that you need to have an X and a Y in order to pull it off. How do you guarantee that movable has an X and a Y position? Anything that's movable has an X and a Y position, and also demonstrate to anybody who's implementing it that you're going to have to specify an X and a Y position if you want to use it. would be the easiest way for us to demonstrate that we guarantee this is an x and y position. I'm going to sync up to the Git repository too, if you want to sync up where I'm at this point. Alright, so that's done. You can check it out, so pull it if you want to sync up. Someone said X and Y fields, but remember we can't still because interfaces have public static final fields, and we don't want every movable object to share the same X and Y. We need them to have their own X and Y that update. Well, assign X and Y position is kind of the same thing as place, isn't it? I think. So the Discord recommendation is that assign X and Y position, but that's the same thing as placing it, I would say. A place is probably the better name for it. Yeah. How do we guarantee that anything that implements this is going to have an X and a Y field without actually saying so? Like, if we can't specify that it has an X and a Y field, what's the next best thing? How do we guarantee that something has an X and a Y field? Well, the common approach, I guess I'll give everybody another minute to think about it. How would you guarantee that anything that is movable or has a movable, see, I used the adjective, so now it's weird. Anything that has a movable has an X and a Y field. Okay, so in YouTube we have part of it. This is a good one, right? We have a set X and a set Y. So if we have a set X that takes a double, oops. Okay, and a set Y that takes a double. Well, then we've at least guaranteed that you can set the X and the Y position, which means that you need to have something to set, presumably. You could leave these blank, of course, and that's always an option with interfaces. Okay, so we've got set X and set Y. What other thing might we want to guarantee in order to really clarify that you need an X and Y variable? And this isn't that dissimilar from place, by the way. It's set X and set Y are pretty much the same thing as place, just two separate steps. That's right, a getter. So if we have a get X and a get Y, get X, get Y, double and double. If we have a get X and a set X, it's pretty clear that this is supposed to have an X and a Y position. So it's pretty clear what the promise is in this case, is that the object has to have an X and a Y position. What other promise might we want to make besides the ability to place? Well, I think you probably want the ability to move too, so I'm going to call this, let's call it move, double X, double Y, and this is going to adjust the X and Y position by values given. Okay. So I think that's everything that we really need to promise in order to make an object movable. It has an X and a Y, which we've guaranteed by just saying you need to implement these get X and set X and get Y and set Y methods. Well, if you're doing that, then you probably have an X and a Y variable. But let's see how that plays out when we implement our movable in car as well. So I'll add it to the list. I'm implementing ignition, engine, and now movable as well. Again, I'm going to add the unimplemented methods. So now that I have all of these, it's quite a bit of baggage here. I really have to scroll. Now that I have all of these, how do I want to implement them? So what do I want to do for set x, set y, get x, get y, place, all that stuff? How do I actually want to pull these off? I ask because we've been doing it a particular way so far, and that way has been to create something like this. So we create like a rectangle 2D dot double, and we call this, let's say, the display of the car, right? And then we would do something with its x and y position, and yada yada yada. So can we do that? Can we still do what we've been doing with display? Let me just start it off with some arbitrary values. Let's call it rectangle 2D dot double. It's going to start at 0, 0, with a width of 100 and a height of 50. Sure. Okay, so I just picked some values to start it off. So what should I do for like my set x, set y, get y, all that stuff? Let's start with set x. What should set x do? Do I need some more fields? Can I do it the way we've been doing it? How should I start with set x? Yeah, we can do it the way we've been doing it. Assuming that the car is just a single rectangle, we can continue to just anchor our x and y to the display, even if it's not just a single rectangle. I like to do it this way. I like to have everything anchored to one display like we've been doing, and then all the ears and stuff, they're based off of that one. That's fine. You can also make your own x and y variables. I've seen a few people do that too. Those are both fine. So it depends on what you think is easier to conceptualize. I don't like having to create those two extra x and y variables to keep track of, because then I get confused. I forget to update them. Maybe somewhere it gets confusing. I always remember to update the base displays x and y, and that's a lot easier for me, at least to diagnose when there's a problem. Both ways are fine. So you could make another x and y variable, or you could do it the way we've been doing it and use the displays. So I think we're pretty familiar with this, so let me go through and write all these the way they would be. At any time that you finish implementing your interfaces promise, make sure that you get rid of that to do auto-generated method stub. That's just supposed to be a reminder to you to complete it, that Eclipse has auto-generated for you and that it's not filled in, that it just returns the default value. Display.y, and then place is just a combo of these two things. And move is a very similar. Rather than just sending equal, it's plus equal. Okay, so that lets the object move about on the screen. And now presumably we also want to be able to draw it to the screen, so let me write another interface for the object's ability to be rendered to the screen, the ability to be drawn. What do we call that? What should an interface that promises that this object can be drawn to the screen somehow be called? The naming of interfaces is a very important game, because the interfaces is how something written by one programmer will usually interact with something written by another, or oftentimes at least. Objects obviously interact too, but interfaces connect bigger pieces of code, and so good naming and good documentation in interfaces is even more important. So what might we call an interface that enables you to get drawn somehow, or to appear on the screen, whatever you want to call it? drawer works. If you want to do the noun version, then drawable. Drawable's my preference. I like drawable, but it's the adjective, and some people say never use adjectives, so they would probably go with drawer instead. Drawer sounds stupid, but that's what we get. So some people would prefer to do something like renderable, which brings you to the most common choice, I think, for when something is drawable to the screen is renderer is what you'll see most often. So if something can be drawn, then it has a renderer, something that renders it to the screen. That's pretty complicated. Another one you'll see sometimes is actor. So if something can be drawn to the screen, then it is or has an actor component that's drawable to the screen. That one's a little bit more confusing. But let's use the one that both people in either chat propose because I find that less confusing. I like the adjective one, so we'll call it drawable. Alright, from what we've learned so far, so in the swing library, what do you need to guarantee in order to be drawable? What methods do you have to guarantee for an object to be drawable? So the JPanel, somebody proposed, what might we do with a JPanel? I don't think we need to guarantee a JPanel. We've never drawn anything to something other than a JPanel, but it is technically possible to draw. We definitely need that draw method, though, from the YouTube chat, because everything that's drawable needs to be able to draw itself. So we'll call this public void draw. What arguments does draw need, if any? What arguments does draw need? From what we've learned. Somehow I developed an extra tab. Yeah, we need that graphics 2D if we're going to draw to swing like we've been doing, so we'll need that graphics 2D object. We can describe this pretty simply. Draws this object to the screen. How can we guarantee that this object actually has something to draw? Can we even do that? Should we even do that? We can. This is one of those situations where it's definitely up to you. We could do something like public shape get drawable base, and this is going to return, let's say, the drawable shape. I'm going to import shape that makes up the base of this one. So let's say you wanted to do that. Returns the base shape that this object uses to draw itself. Okay, this is going to be weird. We could have a set shape too, but that'd be weirder. We probably wouldn't change the shape. We probably wouldn't change the way an object is drawn, at least not in any of the examples we've done. There are definitely examples where you would, but we've never done that. We always draw the same kind of thing. Except even when we changed from circle to square, the easiest way to do that was to have both and to flip between them. So let's go with this for now and not add anything else to it, and then I'm going to implement that too. So we've got quite a laundry list of stuff that we've implemented here, and it's not unusual to get into lots of implementations like this as your program gets larger and larger. Let me implement these two. Alright, so what do I need to do in order to draw it? So to fulfill my promise that this object is drawable, what do I need to do in order to draw it? I want to draw the display shape that I had there, so I'll do that. I'll set the color to black, let's say. Usually we have the ability to set a color. That's usually how we've done it before. Okay, so let's say I want a color. There's a color. let's say I want a color, so I'm going to set the color to that color and then draw itself. We've done that before. Anything I should add now that I support the ability to have a color? Is color an element of being drawable? Does having a color means is that part of being drawable? Is having the ability to be drawable part of having a color? Yeah, sure. So shouldn't that be an aspect of drawable? Yeah, probably. There should probably be some kind of color, get color here. Should return the color that the object is. That seems pretty reasonable. We probably want to have some kind of set color here too. Set color. Let's see. Right, so we probably want to make some of those guarantees on the interface as well. So sometimes you'll see your interface's functionality grow as you discover more things that are a part of it. And that brings us to one of the other letters of the word solid. It brings us to the I. So we'll go back to this again. You don't have to get it now. But the I in solid stands for interface segregation. And what that basically means is that every interface, much like the S stands for single responsibility, interface segregation basically means that every interface needs to do its own thing. You don't want to end up with one giant interface that does everything. So you want your interface to be specific to a single little piece of functionality that it promises. So in this case, we have our drawable interface. And originally, it just promised that the shape could be drawn to the screen. Now it added an extra promise. Now it adds the promise of being able to get and set color. That might be a violation of interface segregation, and it might not. It depends on how you think about it, how you want to abstract it. You could make another interface to support the color. What would you call that? If you didn't think that the ability to get and set color was an aspect of being drawable, what else could you do? What other interface could you separate it out into? So if you didn't think that getting and setting color were part of the ability to be drawable, so if that's not an aspect of being drawable, what else could it be an aspect of? Yeah, it could be something like colorable. Alright, so that brings you to interface segregation, but you can see how that ends up with a lot of interfaces very quickly, and the advice that interface segregation gives us is that it's better to have a lot of little interfaces than one big one, because when we have one big one, let's say that we have an object that we make later that's drawable but doesn't have a custom color, right? Then it's got these two methods for nothing. And so the consequence of having that big interface was that, one, we have two methods we don't need now, and we're probably going to leave them as stubs like this, or not do anything with them. And number two, our interface's promises have weakened, because now that there are objects that implement that interface, but then don't actually do anything with it. So it's fine to have objects that implement interfaces and don't really do anything with them. In fact, we've done that all the time. If you look at all of the swing examples we've ever done, we have all these different, look at a simpler one. We have all these different guarantees that the interfaces give us, all of these different methods, and we only use usually one or two of them. That's fine. But the more you have like that, the more promises your interface makes. Every object that implements that interface has to have a method for all of them. And you don't want to end up in a situation where you have objects implementing an interface but only using a very small fraction of that interface's capabilities. So keep in mind that once your interface grows beyond a single responsibility, consider making another interface instead. But in this example, we'll keep it like this. We'll just assume that anything that is, whoops, anything that implements drawable also has a color option. Alright, get drawable base. What should I do? This is supposed to return the base shape that the object uses to draw itself. How can I complete this? Yeah, I could just return display. Display is a rectangle 2D, so I can actually be even more specific on car. Instead of returning the shape, I can actually return the rectangle specifically. And you'll notice that this is not a problem because we promised to return a shape. So in drawable, we promised to return the base shape. In car, we returned a rectangle, but rectangle extends shape. So a rectangle is a kind of shape. So even though we've done something that's actually more specific here, we've still fulfilled the promise to return a shape. And so this is something you'll see occasionally, again, when you have a much bigger program with lots of different classes. You can go a little bit above what the promise asks you. So if you're only asked to return a shape, you can actually fulfill it a little bit more specifically. You could return a subclass of shape. Probably won't really come up much in any of the stuff that we do, just because we don't usually get to the point where we have enough classes to merit it. Alright, well, we've got a bunch of different stuff that we can do here. Let's go ahead and draw it to the screen now. So I'm going to go and copy my display from one of these swing starters I've got here, so I don't have to rewrite it. Okay, I'll copy that in there, and then I'll copy all the driver code to get it started, so I don't have to rewrite that either. Cool, so going back to the driver for my cars here, let's add all that stuff in there. Got my display, 800, 800, go with the white background, and all this good stuff. Now, generally speaking, we've created and messed with all of our objects on the panel. That's how we've kind of done it most of the time. So let's, I guess, do it a little differently this time. Let's mess with them in the driver, just to keep familiar with that. So I'll call this the interface intro. Okay, and do car dot, let's place one at 300, 300. Let's place the other car at, let's place the second one at 300, 300. Let's place the first one at 100, 300, sure. Alright, if I run this, I'm going to get the display to pop up, but obviously the cars aren't here yet. So how can I get the cars to draw to the screen? What element of the cars actually matters in terms of the panel? What does the panel care about? So if I look at the display, if I look at the panel, what's important to the panel in terms of what I actually want to do? Well, the only thing that's actually important to the panel is that I can draw things on it. And number two, the receiving of inputs matters as well. So how might we do that? Let's look. Alright, so one thing that you can do is create objects that are instances of an interface. And this is a wonky thing because we can do something like this, for example. We can do drawable equals new car. Because cars have a drawable component, which means that we can just access that drawable component only, and look at only that element of the car, only the contract that guarantees everything related to drawing. Interesting. Alright, so what else can we do with this syntax? Well, we could make an array of drawable things. Okay, valid syntax here. This creates an object, a car, that stores a reference only to its drawable interface. Right, and instead, I'm going to create an array of drawable things. Let's call it new drawable, we'll make it 10 big. And let's say that I want to draw all of the drawable objects on the screen. Well, I will, in my paint component, do a loop there. So for drawable D in my array, I'm using that fancy for loop syntax to get us more familiar with it. So for the drawable D in my array, I have to do a null check. So if D is not equal to null, then I'm going to call the draw method for it. That allows me to draw all the drawable things that exist on the screen. Okay, so I have a drawable array, and I have the ability to draw everything in the drawable array. So I'm going to call the draw method from everything in the drawable array. Now I just need to connect the dots. How do I store my cars in the drawable array? So I've got my code here in driver. I made these two cars here. How do I put those up in the drawable array in the panel? How do I do that? Let's just do it anyway, and then we'll do it a better way. So how do I get them into the panel at all? Any ideas how I can get those two cars into the panel? This is a similar question to one of those previous homeworks where you had to connect two panels together. Most people did that in the driver. We might go over that one again. As we get into interfaces more, I can show you the interface way to pull that one off. But how do we do it in this example? How do we link the two cars to this drawable array? Yep, well I already have I have an array of fields, so I'll just put them in the array. But let's say that I want to assign those, so panel dot, what did I call it? I call it drawable. I did, yeah. Panel dot drawable of 0 equals car. What's the problem here? Did I edit the wrong panel? Whoops. That's the problem with copy and pasting. I edited the wrong one. So copy, paste. Oh gosh, where am I? Which one is which? No, that's the wrong one. Did I accidentally import something when I, yep. So it looks like I accidentally imported display. That can happen sometimes. So yeah, if you're seeing missing fields, watch out that you didn't accidentally import something. So I accidentally imported the swing starter there when I was copy and pasting. Yeah, so panel.drawable of 0 will be the one car. Panel.drawable of 1 will be the other car. If we wanted to make that better, we would probably add a method to our panel to let us add drawable things to it. But for now, let's go with that. All right, so here they are. They're both black, though, because I never set a color, did I? So let's do that. Let's do car.setColor. Call that blue. Car.set. Oh, that's not a car. Green, lovely. Blue-green, cool. Okay, so without passing a reference to the car, because the panel doesn't actually care at all about the car, the panel for this particular operation, for the drawing operation, actually only cares about whether or not the car is drawable, or it has a drawable component, has a renderer, however you want to express it. So we were able to draw the car without having to pass a reference to the entire car to the panel. This is really powerful, and this is where the main draw of interfaces comes in. It lets you treat things as just a component, the component that's irrelevant to you about that object. So there's a lot of stuff to a car. It's got an engine, an ignition, and blah, 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 but we don't care about that stuff. We only care about whether it's drawable or not. And then likewise, let's say that we want to be able to move the cars when the arrow keys are pressed. Well, in that case, we only care about the fact that the car is movable. So we'll call that movable instead. And we can do exactly the same thing that we did for our drawable functionality. So if we only care that the car is movable for the purposes of the keys, let's say that I've got two keys here to think about. So if K is, let's track A, we're going to move to the left, get key code, we'll do A, and we'll do D today. So if it's A, then we are going to move it, and if it's D, then we're going to move it the other way. So same thing, I'm even going to copy my loop. Rather than looking through the drawables here, I'm looking through the different movable objects. So for movable M in our array of movable things, if it's not equal to null, then we're going to move it to the left. We have a move method for that. So A is to the left, let's go with -5. No movement on the y-axis. And same thing for to the right. If there's a D, we'll just go +5. And don't forget to repaint, of course. Alright, so for now nothing happens because we haven't added anything to the movable array. And this is one of the disadvantages to doing it this way with interfaces. So now you have two arrays up here. You've got drawable and movable, but that basically have the same objects in them. So they're both holding cars. They're actually both holding the same cars. They're just holding a certain component of those two cars. So if I went back to my driver and I actually linked them together, I would do something like this. I would do panel.movable of 0 and movable of 1 is other car. And so here, if you phrase it like this, if you have it like this in your lines, you can very clearly see that drawable and movable are the same thing. They're both cars. They just happen to be different elements of the same car. So let's see if this works now. I can move my cars to the left and move my cars to the right. Ooh. Okay, so I'm going to sync this to the GitHub repo in a second here, and I'll upload it to Canvas as well for those of you who haven't set up Git yet, but again, I strongly encourage you to do so, and if you run into any problems along the way, just post your question in chat, and I'm sure that somebody will get to you, and if not, I will get to you. Okay, that's it for today. Welcome back from your break. There's a homework due relatively soon. You don't need to use interfaces for it, but you can. There are some aspects of it that might be a little easier, but if you're still not comfortable with interfaces, you can pull it all off with extension. And then the first interface homework will begin after that. Alright, see you next time.